Welcome to Caddy Security Plugins Mini Learning Series by Paul Greenberg. We'll be discussing how we authorize HTTP requests that arrive to Caddy web server. So why authorize? A lot of times when you deal with modern databases, whether it's MongoDB, dgraph, or any other database, ACL's access controls to the web interface API is an enterprise feature, so it requires enterprise subscription and you have to pay money. Sometimes, though, you're doing that for your hobbyist project, maybe a home lab, and you actually want the protection. So Caddy Authorize helps you to protect your uh, otherwise not otherwise not protected database instances online, as well as any other application. It applies to anything. But when I was creating this, I was thinking about like I use a lot of MongoDB, and I used the community version, and I really needed ACL, so I came up with the plugin. So on today's agenda, we'll go through the overview of various topics related to the authorizing of HTTP requests. We'll go into token, what is a token, what is a token discovery, how do we validate tokens. We'll go into the access control and the redirection to the authentication. Then we'll speak about various other features, which is IP address filtering, bypassing authorization for a specific path, injection of HTTP headers based on the content and payload of the tokens, how we can implement API key authentication, basic authentication, and we'll touch a little bit on the Caddy identity context. If you want to ask me questions, you can file an issue on GitHub. I like hearing from you. You can connect to me over LinkedIn, and you can follow me on Twitter. LinkedIn, I use it a lot, so message me. That's fine. So, generally speaking, this is a Caddy file configuration, and it's part of it. So on the left side, you will see Caddy file configuration in a global context. And then on bottom right side, you see a configuration of a specific endpoint where we apply the policy that we create in the global context. So the syntax is the following: order. Um, what is order? Order is a Caddy file directive that says if you see authorized plugin, make sure you are invoked prior to basic authentication plugin. You can go in. You can search Caddy security issues. There is a nice thread on the order and why it exists, but it's think about that each request passes through a series of plugins, series of hooks, and Caddy determines a certain order of how those hooks get invoked. So you want your authorize plugin, the one that performs authorization, to be invoked prior to your content being served. So for example, if you're serving your content prior to authorizing it, the user would see the content. That's the idea. All right, so let's get back to security configuration. So we define what's called authorization policy, and it has a name. Name has a meaning because then you reuse that name in within Authorize plugin. So on the left side, once again, it's a security app. On the right side, it's an Authorize plugin. An app provides the configuration, whether it's for authorization policy, for authentication portal, for messaging credentials, etc. Um, and then on the right side, that's where the action happens based on the configuration provided in the security app. So what do we have here? We say set auth URL. So we're basically saying that if a request came in and the request is not authentic, it doesn't have a token, or token is invalid, we want to send them somewhere to authenticate to acquire the token. So in this particular case, I'm sending that to auth.myfiresgateway.com, and supposedly there, that's where my authentication portal is. I authenticate, I get the token, and then I will come back um, to my app, and I will have a token, and therefore I will be able to pass through the authorization. Crypto key sign verify. So this is the idea here is that I have a shared key that I sign the tokens with. I sign token payload with, and in here I define that key, and I take that from environment variable. So I have environment variable JWT shared key, and it has a value, and Caddy will bring that variable um, into the config, and basically instead of putting secrets in plain text in the config, you basically have that substitution. Then I have two access list rules that where the first one is allows users, so it matches it will look at the token payload, look whether the user has a role, and if that role is off-p/user, then we'll allow the user to pass. So we'll authorize the user successfully. We'll log that attempt at info level, and will not proceed to the second rule. A second rule is a default deny rule. It says match any. So anything that comes to that rule will be denied. It will be logged at the warn level. So that's a high level of what you would need to have at the bare minimum in your configuration. So authorization flow. You have a HTTP request. It came to Authorize plugin, and there is, let's go back, bottom right corner, you have my app. Um, my app has there is a route /users. So in order to get my app -users, respond is also a plugin, and it basically just output the text to the screen. So in order to get a response to trigger to serve, you actually have to pass authorization. So, and for that, you have to, and that authorization is with a policy called users_policy. So authorize with. So now when we go here, the authorize sits before respond. So it will be, Caddy will invoke this plugin before the respond plugin. So you will not be able to get to respond unless you pass authorization. So what does it mean to pass authorization? So the plugin has to find a token in your HTTP request. It searches for the token in cookies, in authorization header, or in HTTP query parameters. Once it found the token, it validates the token. It validates that algorithms, the key IDs match. If there is no key ID, meaning there is a default key ID 0, it validates that. It validates the signature. And then if that is successful, then it goes to the access control. So it looks at the token payload, which we'll discuss later. It will perform those match conditions, and it will either allow or deny it. There is also this thing you saw at the very basic is this match action pattern, but there is also something called path-based ACLs, whereby inside the token you encode the URIs that you would allow the user to come in, and so the plugin would inspect those URIs inside the token and match them to where you're going, and then would allow or deny based on that. So token discovery, let's go. Uh, HTTP query parameters. So this is a basic curl request. So you can pass a token, by providing query parameters, question mark, key equals value. So access underscore token, provide the token. Um, the access underscore token keyword could be changed, and we'll see how. But the idea, you can provide it like that. You can also provide the token, same token via authorization header, once again with curl. You can, instead of specifying the access underscore token, you can say bearer, and then bearer and provide the token. In order for bearer to work, you have to invoke specific Caddy file directive to enable that. So for example, authorization policy, my policy, when I search for things, right, the default is search first in cookies, second in the authorization header, third in query parameters. I can specify, I can limit the search of um, of tokens to a specific part. Like instead of doing all three, I can do only one. So for example, if my application uses cookies only, I can say I want to find the token only in cookies. So I will say set token cookie, and that would cause the Caddy server. Basically, the plugin will not look into the header or the query parameters for the token. I can reorder the sequence of how lookup is done. So for example, if the majority of requests that I'm making, they are done with authorization header, um, then I will put authorization header first, and then followed by query, by cookies, and by cookies. By the way, why don't we do, like, why using query parameters may be problematic is because the URLs may be recorded, and query parameters could be recorded in logs, and therefore you can have a token in your logs. So that's why maybe it's a good idea to disable um, the query parameters. At the same time, query parameters is great for troubleshooting and doing things like experimenting. Now, if you want the bearer token, you need to uh, put a directive in the config, say validate bearer token. If that doesn't exist, authorization bearer will be disregarded. So we went through cookies, headers, and query, and we found the token. So what's a token? Token is a very long string that consists of alphanumeric characters, dot another set of alphanumeric characters, dot another set of alphanumeric characters. What are those alphanumeric characters? Those are uh, that's often called base 64 encoded text. So the the first part before the first dot, it's a header. If we run that header through a base 64 decoding function, and then run through through the JQ utilities that just basically prettifies the JSON. So you will see that the header is just an encoded JSON document. So in the first box that you see, there is an algorithm HS, there is a kid, and there is type. So the type of the token is JWT. That's usually standard across the board. That would be in every token. That's JWT token. Algorithm is HS. Um, think about that think of it as shared key encryption. KID is something called key ID. Um, in theory, you can encrypt tokens that you issue to users, not with a single key, but have a key per user, key per organization, key per application, key per something. And so when authorization plugin gets the token, decodes the header, looks at the key, it makes a lookup in its own local key store and says, do I have the key ID? And if the key ID exists, then the token could be validated. And if it doesn't exist, likely you will not be able to decode it. Um, sorry, you will not be able to validate it because the signature, because you don't have the key that that could be used to validate the signature. So one of the important things, just to like general knowledge, the payload and header are not encrypted. Meaning, if I take a JWT token, I can still run that through base64 decoding function, and I will get a JSON document. Contrast that with something called Paseto tokens, Paseto, where the payload is encrypted. I will not be talking about it here, but if you're interested, um, reach out to me because there is a way to do the authorization based on Paseto tokens here. So let's continue. So if KID is not specified, this means that key ID is default key ID, which is key ID 0. It's omitted because 0, like if it's not if KID field is not in the header, it means that that's a default. Same way how you can decode the header, you can decode the payload. Here's a typical payload, the token payload that is issued by Caddy Authentication Portal. So we have the address field, we have email, we have issued at. By the way, expires at UTC, issued at UTC. Those are fields that I just add. So those are not real token fields. They are just added there to prettify the context, so like one realizes where we are. So not before. Uh, so don't use, like, the idea is NBF is a field that this token can not used before a certain time. Origin local, realm local, roles. There are 3 roles here. Sub, it's like usually used for the username. That's a web admin. So it's all decoded. It's all encoded. It's all encoded in that payload field. It's a JSON document. You can decode it with base64 decoding. All right, so let's go. Remember how in the beginning we spoke about crypto key directives. So crypto key directive is basically configures in order for you to validate a signature, you need to have a key, right, that is capable of verifying the signature. So if the shared key verification, you can specify crypto key verify, and you specify that secret string that you use. In this particular case, you don't specify anything else, and what happens is that the token names that used for discovery. So if you go back to discovery, how we discover token, you can have access token and JWT underscore access token. Those are default keywords to discover the tokens. So when you have this configuration, the access underscore token and JWT access underscore token are assumed, meaning that's part of a configuration. Now, if I want to change the name in the discovery of the token, I can specify crypto key token name, and instead of access underscore token, it will be secret underscore token. Whereas that could be important, you can have multiple. You can. Everyone knows about access underscore token. So if you want your deployment to be more, um, add another layer of protection, you can change the token name to something else, so attackers would not know ahead of time what that could be. It's hard, by the way. It's very hard to brute force a decent a decent JWT token for the purpose of signatures, but just FYI. Next one is I can have that shared key. Remember, like in the initial config that I showed you at the very beginning, um, Caddy I use the env dot environment variable pattern, which is Caddy based pattern. Caddy replaces the variables. I can use environment variables here, and that's already not Caddy. So I can say crypto key verify from env JWT token. So it's equivalent to what was previously shown to you. Now, so I can get even more advanced in my configuration. I can say that instead of me using the default crypto key, I will use a specific key ID that I expect. And I will use actually a different name on it. And so in order for someone to be able to access, like to be able to guess how to access application, they need to now they need to guess what the key ID that you expect from them and what the token name. So before we were speaking about the shared keys, where the signature is done, um, where the signature is where the key that you use to sign and use verify is identical, shared keys. And now you can use RSA, ECDSA signatures, base signatures, and for that you need to generate. Usually there are PEM files involved. So go to the documentation website. You can see how to generate them. But the idea is that you can say crypto key verify from file. So what will happen is the the um, the security app would read the file, and that would become the default key. You see, there is no key ID in the first line. There's no key ID specified. That will be the default key used to verify the tokens. You can specify the file from environment variable once again, or yeah. So the gist of it is that you can also specify the cryptic key as you can say a very specific key, and you can also load that from file. Now, things to know about the file-based keys. Everything is auto-discovered. So if you provide the a PEM file to the plugin, the algorithm, whether it's RS or AS, is auto-discovered based on the content of the file. The key usage. So if you provide a public key, you will not be able to use it for signature. You will only be able to use it for verification. So the key usage, depending on what you provide, the key usage would be predetermined for you. So you don't. In the very early iterations of the plugin, I was hard coding what is that key, what its algorithm and key usage would be, and then I wrote something that basically auto discovers that part for me. There is another interesting part of it. That was I didn't think about it. So there was another creator. His name is Nick Jones. He created um, that concept from directory. And so the idea is that you can point the plugin to a directory, and you can have hundreds of keys in that directory, and the key ID will be in the name of the files. So you can have like hundreds of files with different names, and so the plugin will load all of them and the names, and it will basically have um, it will guess what the key ID from the name of the file where the key is. That's a nice thing where you have a lot, like when you have an when you want to have when you have requests coming with different key IDs and they all dynamic. So that's a way to kind of like you have, let's say, Authentication Portal that generates keys for that signs tokens, and then let's say you have at certain refresh interval, you change the keys um, for security purpose. Let's say every hour, every 2 hours, every 3 hours, six, whatever. And then once you change the key, you drop that key into the verification, like into that directory, and that's all that's necessary. No, like you don't have to configure anything more if you want to, recycle keys over time. Access control lists, pretty trivial. So it starts with ACL space rule, and then within that there is a comment, there is a condition, and there is an action. On the right side, you see once again we match the role, which is auth p user. We let them in, and then we have a default deny in the second rule. You already saw the token on the right. On the left side right now, you have all the fields that you can make that you can match in your conditions. So you can match in roles, email, origin, name, realm, audience, scopes, org, GTI, issued, um, sub, address, method, and path. You cannot, at the moment, you cannot have a match based on any other fields. But if you need that feature, please reach out. There's also a way to do that. Basic syntax. So we have um, the syntax. Initially, it was just match. Then I added this exact, partial, prefix, suffix, regex. So you can have partial match of some field. And you can have a prefix and a suffix match. And you can see in the examples below all the various matches that you can do. Next iteration was I wanted to negate the match. So no partial match, no suffix match email at full bar. So that would match. So let's say you have a domain, an email that someone has from domain foo.bar, and you can say like anyone else who have an email from some other domain that's like that would be that would be the that would be matched. All right. You can also do field exists, so you can say field email exists or female field metadata not exist. That could be a valid match condition. You can also match based on method and path. So you can say match method post prefix match to path foo, and that would be part of the matching. Time-based match conditions. So before I said we can only match on string-based fields, but I'm working right now on the time-based match conditions. So the idea is, say someone got to your key and they're generating keys that have a very long lifetime. And so to avoid to prevent attacks of that nature where you have someone issued a very long a key with a long lifetime where they issued at IAT field and expires EXP field, the difference between them in days, years, whatever, you can have match conditions that save lifetime, that difference between issued um, and expires is longer than, so you can say lifetime longer than 2 hours, deny that. All right, so that will not be allowed. Or lifetime, and then if you have lifetime shorter than X, allow. So you can have a rule that says allow lifetime shorter than 2 hours. And then next rule will be your default deny rule that says deny all. You can also have conditions that say issued X amount time ago. You can have conditions expires in X time. So for example, we want to match if someone expires in 5 minutes, maybe we want to redirect them to reauthorize, right? Or you can have expires X time in the future. That's another condition. All right, actions. Allow, deny. Okay, the gist of it, you can, when your action contains of the following things, you can allow, deny, and you have a keyword called any. So the keyword any means that a match or deny of any of the match conditions. So by default, the action would be applied if all the conditions match. If all the conditions match. However, you can modify that behavior to any if any of them match, right? By adding the any keyword. The stop keyword acts the following. So stop keyword tells the plugin perform the action. So if you had just have allow, it will continue. It will continue to the next rule. So it will continue rule evaluation. If you will say allow stop or deny stop, it means that whatever the decision is, stop at that decision. Counter. You can add counter to your to your to your match to your actions. The idea of a counter is that you can see how many times that rule was hit or missed, meaning how many times the rule was evaluated positively and how many times the rule was evaluated negatively. That could be dropped into the Prometheus exporter, and you can have those counters in the Prometheus. So you can monitor, like if you have excessive amount of misses, and then you have a specific deny rule that specific deny rule that has a counter of hits, meaning that people like a lot of denies. You want to watch that counter. Maybe you have someone trying to brute force into the application, so that's a nice thing to have. Log. If you log keyword works like this. If things is either hit or missed, there will be a log message with the inspected payload, and the log message will be at the level either error, warning, info, or debug, whatever you specify. There are also shortcuts, ACL shortcuts, where you can you can say allow field X with values Y, and then you don't have to put ACL space rule, that big stanza. I prefer not to use ACL shortcuts. I prefer being more expressive, right, in the definition, so it's easier then to explain the policy to other people. But you can still use this pattern. All right, let's go next. Next, path-based ACL. So on the right side, you see a token, and the token contains a path-based ACL. So it has a key ACL, field ACL. Underneath it has path, and then there are various paths that you can specify a path, and you can specify methods and what can be done in there. So in order to enable path-based ACLs, you need to enable validate path-based ACLs as a configuration option, and then you obviously the users need to provide you with path-based ACLs. Authentication redirections, interesting topic. So by default, when token is not found, you will be if you have the set auth if you have the set auth URL directive, that line number one, you will be redirected there via location header redirect. So a browser, your client will be served with location header, and the client's browser will take them to that URL. You can disable that behavior with a line 3. Actually, I'm talking about, you can disable that behavior, that default behavior, by disabling the redirect. We'll talk about it later a little bit. Usually the query redirect parameter, so it will redirect the user to https auth myfiasgateway.com, and then it will use query parameter question mark redirect underscore URL and the URL you're being redirected from. So that redirect URL, that query parameter, could be set with line number 2. You can provide a different value. 3, you can disable redirect query. So you can disable that query parameter. So it will just plainly drop a person at the URL without doing anything else. The redirect status, you can set the redirect status on the redirect. It could be any of the 300 status codes. You can enable a hint, logging hint. So for example, you're redirecting somewhere, and you can say enable logging hint with email, for example. And then the idea is that if you have an existing token, but that token is expired, you're getting redirected to Authentication Portal. The plugin will look at that expired but otherwise valid token, meaning the signature was validated, but it's expired, so you need to re-authenticate. It will look up email in that expired token, and it will provide that as a logging hint. So this way, when you come to Authentication Portal, let's say to Google or something like that, you will, and let's say you have multiple identities, it will help Google to determine which account you're actually asking to be authenticated with. And that would be a true SSO. So user, in the right flow, a user will not even see that there was re-authentication, that re-authentication happened. Sometimes you have a need to redirect from a page that uses anchors, the pound signs. So let's say you know how you have pages where you have links like H1, H2, H3, and there is an anchor pound sign something. So for example, it's Jupyter notebooks have a lot of pounds. So in that case, and what happens is that that pound sign cannot be encoded in the location redirect, because it cannot be captured rather. So in order to deal with pound signs, you need to use something called JavaScript Redirect. So with the line number 2, you can say enable JS redirect, and then instead of using location, you will be redirected with JavaScript. As I mentioned previously, you can disable redirect with disable auth redirect directive. It's when you're setting up Authentication Portal, I strongly recommend disabling auth redirect just for the testing purposes, because you may be bouncing between Authentication Portal and the authorization endpoint. And so in order to eliminate that bouncing and figure out how things work, disable it. So let's go about miscellaneous features. So IP address filtering. On the right side, you have the token payload, and then you have a field called address. So let's say I have a token, and an attacker was able to get to my PC, extract the token, and now they're sitting in their at whatever the location they are, and they're trying to use that token from that location, not from IPC, from their own location. There will be a mismatch in address because the token was issued to me from my home, and just for the sake of like, and so when I'm connecting, the validate source address clause will make sure that the address of the connection to the server that I make matches the address of the token payload. So, and if there is a mismatch, you go back to for re-authentication. It's just a security measure. Bypass your rise. So bypassing your rise works similar syntax as match conditions in the ACLs. But the idea here is you can have you may want to bypass some prefixes and not authorize them. Just pass them through and grant them authorization without actually checking anything. So this is what bypass your right directive does. Header injection. So you can you can you can take fields from the token and you can inject them with X headers, right, or any header name to downstream plugins. So for example, you authorizing a request and you want to take some field, you want to inject it in a header that's passed to reverse proxy plugin. And reverse proxy plugin now will see that header in the request. So to enable it, you need to say inject headers with claims, and that would inject like standard things like subject, username, and roles. You can also inject custom fields, so you can say inject header x picture from picture field. So there's a say my token has my GitHub picture in the picture field. I can have that x dash picture header that will have that URL from that field. You can also strip tokens from HTTP request. Currently, this works with cookies, but just it's a way to not present the token to the downstream plugin. Identity context. So there is something called identity context. So in theory, downstream plugins, the plugins that invoked after this one, would want to see the identity information or access identity information of a user. So in here, this plugin crafts that and injects ID and some metadata in the terms of subject and email. By default, the ID is an email address that Caddy finds. But it could be changed to the username, which is subject, or some other ID. Basic and API key authentication. So a lot of times you would want to do authentication and authorization within the same transaction, so you don't want to go out. So in Authentication Portal, you can create a key by adding an API key that will be a long string. Then it's usually done with the local backend. Then you can use the number 2, the configuration directive with API key, auth realm, local, so realm name must match. And if you say, and if you specify that, the Authorize plugin will take the API key that it finds, usually like x dash API dash key header. It will take that key and it will make a lookup in the local backend, um, and you will be authorized based on the presence of that API key. You will not be going externally anywhere. Just like it will do it. It will do it automatically. Same idea. If you have basic, you can enable basic authentication. So if someone presents basic authentication credentials to Authorize plugin, you can also make a check against the local. One caveat, if that user with a basic authentication has a second factor configured, then that authentication will not pass because of the second factor. But if there is no second factor, it will actually succeed. Think like the way to think about basic auth here in this context is you have some thin clients like transmission, you're doing some BitTorrent or like a TV connecting to the server, uh, these types of things. So I think that the line number one is very appropriate to that. Number two, this is more of a service accounts, API keys, that type of stuff. SSO integration. So you can have, so in here you can have an authentication portal, which has a backend that's based on the GitHub. So it's a GitHub SSO. What you can configure that authentication portal, and then because authentication portal there is a certain structure to the URL. In order to get to the directly to the so you ordinarily when you land to authentication portal, you see a screen with you see the screen with login options. But there is a way to go to authentication portal and being redirected right away to GitHub. You just need to know the URL. So the URL is so if I'm serving my portal from authz proxy, the endpoint to reach the GitHub and being redirected right away is auth2/GitHub. So GitHub in this particular case is a realm. So auth2 realm, and you will be redirected automatically. This way, the whole authentication, like authorization and authentication, will be completely transparent to the user. A user will not see authentication portal screen. They will be redirected to first authorization plugin will redirect them to authentication portal to the GitHub to the GitHub endpoint. All that with 302 redirects. Then they will be taken to GitHub to authenticate. Then they will be brought back to Portal, and then Portal will bring them back to the authorization endpoint. So we'll have my app. I have a route. In this particular case, I have a route to authz proxy, and that's where I serve my authorization proxy portal. And then all the other traffic will hit the Authorize plugin. And so that's kind of the interaction that you can set up that seamless SSO um, with GitHub or Google or anything like Facebook, whatever you want. All right, so we concluded our presentation. Please consider sponsoring me, even if it's $1. I will appreciate that. Start the project, ask me questions, connect. I'm very excited to hear from you. Enjoy your day. Bye bye.